So now we're going to be talking about orbitals. And so for orbitals, in chemistry and in Ochem is probably my least favorite subject. And I think for a lot of you, it's the same. So orbitals can be very, very confusing. But for the MCAT, the one thing that's good is they don't test you on all that much. Okay? So you just need to know a couple things in terms of orbitals and you'll be fine. So don't try to overcomplicate orbitals and hybridization and all this stuff like that. Because it's not that important. They just need you to identify very simple stuff. Okay? So you know how we have s, p, d, and f orbitals. Remember, if we did this in previous chemistry lectures when we had s was the s block, s orbital. We had the p, the d, and the f. Okay, so that's what the s, the p, the d, and the f is. But what they actually look like, the only ones we actually have to need to know what they look like, are the s and the p. So the p is like a dumbbell shaped, and s is a sphere. Right. And so the orbitals are what is the probability that the electrons will be located in that location. So the electrons they have a very high probability of orienting themselves in that dumbbell shape, whereas S is a sphere. Alright? So what happens if we actually hybridize these? So hybridization occurs and we can get something called an SP, an SP2, or SP3. Okay? And this is important just to see in actual bonding what bonds are being made, because this is strictly for one element by itself, but elements don't just solely stand by themselves. If you have, for example, C by itself would be in the p block, but CH4, now you have some hybrid orbitals working and playing a role because there's different bonds that relate to each other. Okay? So what we need to know in that, very simply, are can we identify, is it going to be sp hybridized orbital, sp2, sp3, and they're talking about a specific atom. So they're going to be talking about that specific molecule. They'll say, is the C in CH4 sp2, sp3, sp, stuff like that. Okay? So what we need to know is just, based on how they look, what's their hybridization. Okay? So based on the geometry, linear is going to be sp. And obviously linear is going to have 180 degrees. sp2 is going to have a trigonal planar, and it's going to be 120 degrees. And sp3 is going to be tetrahedral, and it's going to be 109.5. So if they ever ask you on the MCAT, they give you a molecule like this one right here, and they say the carbon molecule, is it sp2, sp, or sp3? We know based on the geometry what it's going to be. And we know because it's a trigonal planar geometry around that carbon atom, we know that it has to be sp2. Don't overcomplicate things, just think of it in that sense and you'll be completely fine. Okay, so here's an example. We have, similar to the one I just mentioned, we have formaldehyde right here, and they're asking what is the hybridization of that carbon molecule. And we know it's trigonal planar, so it's got to be sp2. Okay? Simple. That's all we need to know. Okay? Now we need to know sigma versus pi bonds. Okay, so sigma versus pi bonds, they can get kind of tricky, but all we need to know is that sigma bonds are single bonds. Okay? They're between single bonds. For example, right here is going to be a sigma bond, right here is going to be a sigma bond, and also right here is going to be a sigma bond. But a pi bond is a double bond. But for every double bond, you're going to have one sigma and one pi. And we'll see that later. Okay? So a double bond has one sigma, one pi. What do you think a triple bond would have? Well, it would have one sigma and two pi. Okay? So pretty much every bond has to have some sigma bond. Okay? Every bond has a sigma bond, but it can have variable number of pi bonds. Okay? So a sigma bond is a bond between any hybridized orbital or even the s orbital. Okay, versus a pi bond, which is a bond between p orbitals. So these are the p orbitals, bond with electrons between the two, and this is a hybridized orbital, sp3, and also s. So you can think of this like the C in CH4. Okay, the sp3 is the C, and the H is an s orbital. So now we're going to be doing a very basic example, and we saw this previously in the one we just talked about, is how many sigma and how many pi bonds are in this molecule, which is formaldehyde. Okay, so what we do is we just count the number of bonds. So the number of bonds is going to be 3. that's going to be our number of sigma bonds. Okay, now we have to count the number of either double or triple bonds. And the answer is one double bond, so that'll be 1. Okay, if we had a triple bond, then we would say 2 pi bonds, and so on and so forth. Okay, so now we're going to look onto degrees of unsaturation. So what are degrees of unsaturation? So degrees of unsaturation will tell you how different from a saturated molecule it is. So this is somewhat of a tangent, but very relevant for us. It'll help us understand what I mean by that. So remember, in fatty acids, we have saturated and we have unsaturated fatty acids. Okay. So this right here is a saturated. This is unsaturated. So unsaturated means it's different from the straight chain alkane molecule. Okay, it has unsaturations, which are these double bonds. Okay, so degrees of saturation will count the number of double, triple, or cyclic molecules. Okay, so the degrees of unsaturation for a double bond is 1, for a triple it's 2, and for a cyclic molecule it's 1. And you can obviously have combinations of both of them within there. Okay, so the important part of this is how can we identify molecules. For example, in NMRs and IRs, we'll use these degrees of unsaturation if they just gave us the chemical formula to identify which molecule we're actually looking at. Okay, so for example, what if they gave us, it's easy if they gave us an actual molecule and we can just count the number of degrees of unsaturation by this rule right here. But what if they didn't? What if they gave us, actual chemical formula? So for example, what if we were given this molecule right here, CH2 and an H? Okay, so what is the degrees of unsaturation? Well, we have an equation that we can do that right here. Okay, so if we were given this equation, the equation says C is the number of carbons, H is the number of hydrogens, X is the number of halogens, and N is the number of nitrogens. And so it may seem kind of complex at first, but it's pretty simple. You should be able to memorize that fairly easy. And these are 2s, so 2C plus 2 and over 2. Okay, so all we do is just plug it in. So for this molecule right here, we know that it's 2 times 1 carbon plus 2 minus the number of hydrogens, well there's 3, and then plus N, so plus 1. We divide that by 2, and so our degrees of unsaturation is 1. And so, based on the NMR, based on the IR, we can actually make a molecule from that. And so the molecule that I was thinking of when I wrote that out was this. Okay, so that's why we had that 1 degrees of unsaturation, and that should match up. So you can practice on your own, just making these different molecules and seeing what the degrees of unsaturation is, and just checking on it by looking at it and saying, okay, yeah, there's one double bond, so 1 degrees of unsaturation.